Okay everyone, let's go ahead and start off with section 18H, which is called sets and Venn diagrams. Again, we have gone over most of these things in the IGCSE course, but let's go ahead and review them. Now, by definition, what we have is a set. And we're going to say that a set is a collection of items with a common characteristic. Okay, so if we go ahead and take a look at what we have up here, of course we have a set. And we have all of these different things. Of course, all of the things that we have in here are fruits. Now, all sets are going to be designated with a single capital letter. So let's go ahead and change some of these so that we can deal with a capital letter. Let's say that these are all the red fruits, so let's go ahead and call this one R. That's the set R. Let's go ahead and call these right here, which is the cherry, the apple, the mikan, the orange, and the lime. All of those are round fruits, so let's go ahead and call that O for round. And of course, these over here, the banana is the only long fruits, so let's go ahead and call that L. Okay, and then the mango and the papaya, of course, they're not round, nor are they red, nor are they long. So we're just going to put them in a category among themselves, and we're just going to call that, we're going to call them a part of the fruit set, because they don't further fit in some of these other characteristics. Now, we're also going to go ahead and say that U is going to be the universal set. Now, for this particular purpose, for this particular example, our universal set is actually fruits, because of course the only thing that can go into here are fruits. So what we can do is we can actually go ahead and change this. Use the letter F to represent fruits. So everything notice is in here is a fruit. And then of course the red fruits, the orange fruits, the round fruits, the long fruits, and those which do not fit but are still fruits. Okay, and then we can talk about this here. We said that X is an element of A. That's how you read that. Now notice that elements are always lowercase letters, whereas the sets are always uppercase letters. So let's go ahead and take a look at this. We can say that the strawberry is an element of R. The cherry is an element of R. The cherry is also an element of O. The lime is an element of O. The lime is not an element of R. The banana is an element of L. The only thing that we can say at this point for the mango, the papaya, is that they're an element of F. And of course, all of these fruits are an element of F. Okay, now let's go ahead and take a look at the next one. It says A prime is the complement of A. So let's just go ahead and talk about, say for example, R, which is composed of the strawberry, the cherry, and the apple. If I was to go ahead and say R prime, then really what I'm referring to is the mikan, the orange, the lime, the banana, the papaya, and the mango. Now let's say, for example, that I wanted to go ahead and say the L prime. What would L prime consist of? L prime would consist of the papaya, mango, strawberry, cherry, apple, mikan, orange, and lime. Okay, let's say, for example, if I did O prime, what would O prime be? O prime would be the strawberry, the mango, papaya, and the banana. Okay? And then if I was to actually do F prime would be all of those things which are not fruits. Okay, let's go ahead and take a look at N of A. This refers to the number of elements in A. So let's say, for example, if I want to talk about the number of elements in R, so I would just do N of R. N of R would be 1, 2, and 3. So N of R would be 3 because there's 3 fruits in R. If I was to go ahead and take a look at the N of L, then of course we would have 1 because there's only 1 element in there at this point. And if I was to go ahead and take the number of elements in F, then I would just add all the number of fruits that we have, which would be 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now, the other one that we're going to look at is A union B. Okay, so that's how you say that. That is A union B, or the union of A and B. Now, what that means is that means this. It means all elements of X such that X is an element of A or an element of B. Now, if I was to go ahead and talk about, say, for example, using this, the red or the union of R and O, so that would be R union O, then what I'm talking about is the strawberry, the cherry, the apple, the mekong, the orange, and the lime. Now, if I was to do the O and L, the O or L, I would basically be referring to the mekong, the orange, the lime, the cherry, the apple, and the banana. If I was to do R or L, then I would do the strawberry, the cherry, the apple, and the banana. If I was to do L, let me see. I think that's really the only things that I can do at this point. Okay, so let's go ahead then and take a look at the next one that we have is A intersect B, or the intersection of A and B. And this is going to be the elements X such that X is an element of A and it is an element of B. So if we were to go ahead and say what is R intersect O, the only thing that you could refer to is the cherry and the apple. What if I was to go ahead and say the intersection of O and F? Then I would talk about the mekong, the orange, the lime, the cherry, and the apple. What if I was to talk about the intersection of F and R? Then that would be the strawberry, cherry, and the apple. Now, disjoint sets, okay, two sets are disjoint if the intersection of those two sets provide you with the empty set. In other words, there's nothing in the resulting set. So if we were to take a look at this, which two sets are going to be disjoint sets? Well, if I was to go ahead and take the intersection of O and L, those are disjoint because there's nothing in common. If I was to take the intersection of R and L, that would also be two disjoint sets because there's nothing in the intersection. Now, if we have two sets such that there is no intersection, no elements in the intersection, then we can also say that A and B are mutually exclusive sets. Okay, in other words, they don't share anything in common. They're mutually exclusive. Okay, and those are all the different types of notation and all the different types of terminology that you need to know in order to work with sets. Now, hopefully some of you recall that some of this, even though this looks a little unfamiliar right now, we've actually seen this type of notation before. Let's kind of go back, and even this one here. Now recall that when we talked about a sequence, we said a sequence is a set of numbers with a pattern. Now we didn't focus on the set part, we focused on the pattern part. But now we also can go ahead and tie it into what we have here with the sets. And so notice that when you actually looked at the definition of an arithmetic sequence, notice that the arithmetic sequence said this. It says the set U sub n is arithmetic, or the sequence of numbers U sub n is arithmetic, if and only if there is a common difference for all n is an element of Z positive. Okay, so look at what we have here. We're talking about sets. So that's why we have to use the set notation here. And notice that we've also used this because we're talking about an element in a particular set, and the capital Z was the integers, and the capital Z with the positive was all positive integers. Okay? So anytime that you're actually dealing with sets, you need to use what is called set notation. Okay? And the set notation involves the braces. Okay? So if we wanted to go ahead and take a look at how we say this, we say the set X such that X is an element of A. So notice that you're talking about the elements, and that has to be consistent here as well, which are elements of which particular set. And so that's why this is called set notation, because you're using the braces as well as designating what those elements are. Okay, so we'll go ahead and take a look at section 18H, and we'll practice a couple of problems in class the next time that we meet, and we'll see if everybody can use the notation properly and understand exactly what the notation is actually referring to. Okay, give it your best shot, and we'll see how everything goes. See you next time. Bye.